I think we can bring to the floor now Xabi, Ercilia, and Robert that have the task indeed to respond to all the requests that they have received. I know that Xabi has some slides.
Okay, should I go?
Our investigator.
Thank you. My PhD student.
Yeah, also.
Okay, so I prepared some slides to fuel the discussion. First of all, I want to say that I think this is a great initiative and it's very important talking about misclassification bias because we, or most of us, are in the business of pharmacoepidemiology, which means generating evidence to inform decisions. So we need to estimate what works, what doesn't work, what harms, what doesn't harm. If there is misclassification bias, our estimations will be wrong, and that won't be useful at all. I have a couple of slides that talk about myself. I don't love talking about myself, but I think these represent the presence of measurement error, misclassification bias in somebody who has a training like myself on different health sciences, right? So I have training in, I've been through medical school, a master in biostats in EPI. I've done academic research in EPI, and now I work in a company that devotes most of the work to do regulatory studies. I had some exposure to confounding in medical school. They explain you that to estimate an effect, you need to compare two groups. You need to compare apples to apples, essentially. When I did a master in biostats, they also explained me very well confounding. And then once you put the EPI hat on yourself, confounding is all over the place. Measurement error, you get pretty much no exposure during medical school. They teach you what is sensitivity, specificity, and predictive values. That's it. In the biostats master that I did, I had something about, again, predictive values, etc. And then once I landed the EPI world in the master in academic research, there is some consideration about the measurement error, but not close to confounding. And now that I work in RTI and we are involved in a lot of regulatory studies, of course, whenever there is a regulatory study, there is serious discussion about validation. So I was asked to come up with a research question, and what I'm going to do is articulate that research question in the form of a target trial, and then I'm going to review some of the recommendations that the presenters gave us and see what should I bring, what extra steps should I bring to this study. The research question is, what is the effect of drug X, let's say it's a biological drug, on the incidence of malignancies compared to no treatment in patients with rheumatoid arthritis? Now there are many drugs that are immunomodulators, and the same way that modulating the immune system can help an autoimmune disease, it can also affect the incidence of cancer because the immune system has a role there. So in my target trial, I will evaluate adult patients diagnosed with the disease who have not received treatment ever. My treatment strategies will be as simple as they can be, just initiate the drug versus do not initiate the drug. So the comparator group is no treatment. In my target trial, I randomize people to both groups. The follow-up starts at randomization. The outcome is cancer, diagnosed within 5 years. In this trial, I can estimate both the intention to treat effect and the per protocol effect. And the analysis plan will be as simple as it can be. I will assume there is not right censoring, so I'm going to just compute a 2x2 table to have an estimate of the risk. That's my research question. When it comes to emulate this question with this trial with observational data, the eligibility treatment strategies, the follow-up, and the outcome are going to be the same. The assignment procedure has to be different by necessity because in real-world data we don't have randomization, so I will have to make the groups comparable somehow. I'm proposing to do one-to-one matching here. And the causal contrast will be the observational analog of the per protocol effect, and the analysis plan is going to be the same as in the target trial, with the only add-on that because the control group is no treatment, those persons can have several time zeros, so I'm going to emulate a series of trials. Okay, this is this is my research question and how I plan to address it. Let's see what have we learned from the speakers today. I've put them in a convenient order. From Vera, the feedback we got from Vera gave me the impression that she's a very seasoned researcher, because of course she points out that you have to worry about the validity of your variables. Do you have algorithms? She also considers that there might not be validated algorithms. Not even that. There might not be validated algorithms, and you might not have the money to validate everyone. So she proposes or give us options to see whether you can do a validation, and if resources are limited, what is the least that can be done. And I also like very much Elisa's remark, because she says, look, you have to validate even if you do target trial emulation. Which is, it's true, because target trial emulation was never intended to control for confounding or to solve measurement error. Target trial emulation gets the low-hanging fruit. It solves bias due to selection, solves bias due to lack of consistency of your interventions, and that's what it does. The other part of the low-hanging fruit is having measure confounders, right? Those aspects are easy to solve, but there are other aspects that can bias your study that are much harder to solve, and one of those is measurement error, and that's why I'm very happy that we are having this conversation here. Now, we also had advice from Julia and Giuseppe. I loved that Julia said that you have to talk to the coders, and this is very important. Because you can have a very nice research question, you can have very fancy statistical methods to adjust for time variant confounding, to clone certain weighting, sequential emulation, you name it. But if you know how to change your data, you're not going very far. So I think that is very important. Exactly. You can go very far, but in the other direction. Correct. And Giuseppe goes in a similar direction. He says, look, you have to characterize very well your data source, propose to use the diverse framework, and what each component of your data set is bringing to the characterization of of your outcome. In this regard, I was going to present a study we did in RTI, but I'm going to be very quick because I know we're very late in time. So this was a study where, using CPRD, we looked at the different sources of information inside CPRD, which are primary care physicians, hospitalization information, and cancer registry. And we look at what was the overlap of the validated cases according to the source they were coming from. And you can see that the overlap is not perfect, but what is really interesting about this is that it's very different depending on the type of cancer that we studied. On top, you can see breast and prostate cancer, there was very good overlap. For other tumors like lung, pancreas, and kidney tumors, there was very bad overlap. What's the difference between the tumors on top and those below? Screening. You screen for breast cancer, you screen for prostate cancer. That means you detect early tumors that don't need as aggressive interventions as the others. So this goes along the lines that we were discussing, that you need to know what's in the data and how the information in your data relates to your needs. So I added here my first addition to my target trial emulation, which is that I'm going to validate the outcome and provide the validity measures. Then we had the talk from Anna Schulz, which goes one step forward. She takes the results from the validation and incorporates those to your effect estimations. And you can do that more in a more simple way with a quantitative bias analysis, or in a little more involved way with a probabilistic bias analysis. I really like that because it's essentially free. It's a back of the envelope analysis. You need a formula, you need a distribution of your parameters, and there you go. So I think it's also a good idea to implement a probabilistic bias analysis to this research question. And finally, Giorgio mentions that, well, several recommendations that goes along the lines of other um, presenters, but what I like is the last one. Can you assume that sensitivity is not differential? So it's important to be transparent about your assumptions. Whenever we do validation, whenever we do probabilistic bias analysis, we are making assumptions. So we need to be transparent also in the protocol of our study. And finally, Marco also gave very interesting remarks, but this is above my head. I want to be honest that AI is above my head. So I added to my protocol that I'm going to be explicit about the assumptions behind the bias analysis, and that I'm going to stay curious about the role of large language models, because I think that using a large language model for validation with a data set, for example, like Nicolas in France, that's going to take that's going to be not going to be easy, because you need a lot of computing resources and you need them to be local probably. You cannot, well, I don't know. There might be alternatives. So this is what I was able to do with all the recommendations that I received and my mock question.
Thank you so much, Fabi. So I'm happy that we had some rows added to your target trial emulation. The one I think came from, I guess, Vincent, is that actually the similar rows could go in the first row in the eligibility, because you are assuming you have MS. Yeah, fantastic. Thank you very much, Shabi, for accepting also this game.